Chapter 1, paragraph 5 is about phases, transition, and separation. Oh. Okay, first about phases. There are basically 3 phases: gas, solid, and in between there's liquid. So gas, solid, and liquid are the 3 phases of matter, and I know there's plasma and we act like it's not there. So a gas is a substance that is invisible and it's unable to catch. So like air around us, I cannot see it, and I cannot just take a cup and fetch it and have it in my hands. So it's unable to do it. A liquid is visible but unable to grab. So I cannot take, like, I can fetch water with a beaker, but I cannot grab it like this, just take it from my table like I can with my pen. I can just grab my pen. I cannot grab water. Solid is visible and you can grab it. Like this pen is solid, I can see it and I can grab it. That is not the case with liquid, because I cannot grab water like this. It will just flow everywhere, mostly where you don't want it. A substance can transfer from one phase into another, and that's what we call transition. And those transitions have a name. And I hate to break it to you, but you have to know all those names. Some of them might sound familiar, some of them don't. So let's start with the easiest one. From solid to liquid is what we call melting, like ice can melt. The other way around, solidifying. So melt, solidifying. Then from liquid to gas is called evaporation. You might have heard of it. And this one back is condensation. Then the last two, which you probably never ever heard of, this is sublimation. And this is deposition. This is what happens when it's very cold outside, actually freezing, and it's very humid, and then you get all this ice on the trees. That is what's happening with deposition. Sublimation, you hardly ever see it. That is also because solid turns into gas, but it's hardly ever seen. Then liquid to gas is what you actually just do when you cook. So then all the water evaporates. Condensation is what you see on the window, on a cold window. When you breathe on it, then it gets wet like a mirror in the bathroom. That is what we have, condensation. So the gas water turns into liquid water. Then melting, mostly seen with ice, but also with butter in a pan. And the other way around is, well, actually the same, but then when making ice, or just leaving the butter to stand, and then it will get hard again, and that is what we call solidifying. Okay, back to the gas, solid, liquid part. To mix them. Like when I have a solid, all the particles, the molecules, are all perfect arranged. so they are arranged perfectly. As you can see that they are all packed closely, which is the reason why you can grab it. So the way the particles are packed, they are so close together that it's impossible for them to move, and that is why you can grab it, and that is why you can see it. So closely packed, unable to move. The particles, obviously the solid itself is able to move. So a liquid also has particles that are closely packed, but they are not arranged properly. They are just somewhere that you want to see them. So here you can see that they're all in lines, and a liquid is just like floating around. They are closely packed, but they are able to flow. So they are able to move. Which is why it's unable to grab a liquid, because if I grab it, all the molecules will just flow away. So the solid is closely packed. I can grab it because they are so closely packed. A liquid is not. This is what we call micro level. So micro is with particles, and macro is what you can actually is bigger, and mostly you can see it. A gas is this. They are most definitely not closely packed. So they're far apart, and they are obviously able to move. They are not closely packed, that is why they are invisible. They are not close enough together to form balls, so it's impossible to see them because they are way too far from each other. Okay, so when I'm going to heat it, so while heating it, something happens to the temperature. So the temperature changes. The temperature of a substance is basically how hot it is. In Holland and in Europe we use the Celsius scale. In science we use a different scale, it's called Kelvin. From Celsius to Kelvin, to calculate that, you just add 273. The other way around, obviously just minus 273. So this way, minus 273. So that makes like 0 degrees Celsius is 273 Kelvin. So 0 degrees Celsius is 273 Kelvin. It's not that hard, you just have to know that. In America they use Fahrenheit, which is even weirder, and luckily we don't do that. When I'm going to heat this, there's a difference between a mixture and a pure substance. We already know a mixture is more molecules, different molecules. And pure substance is one kind of molecules. And you can actually, you can actually see it when you're going to heat the stuff. This is a graph of heating a substance. I'm going to use, this one is the temperature, and this one is the time, small t. I'm just going to start here, and I'm going to heat up the temperature. Obviously it's going to melt first, but eventually there will be a part where it's just going like this. So you do heat it, but the temperature doesn't go higher. Then eventually it will go higher. I will stop here again. It will go like this. Here the substance is solid. Here it's melting. Here it's liquid. This is boiling. And this is gas. This is of a pure substance. So when I have a mixture, it just looks different. I have tea. I have tea again. But then it goes like this. Here there are, in the pure substance, there is a melting point. So this is a melting. Namely this. There's also a boiling point. This. Then, in a mixture, there's a melting range from here to here. This is solid. This is liquid. This is gas. There's also a, sorry, it's a bit wobbly, boiling range. So this is melting. Can you still see it? Almost. Like this. Okay, and this is boiling. So you can see that there's a difference between a pure substance, which has a boiling point and a melting point, and with a mixture which has a boiling range and a melting range. So you can see the difference pretty clearly. If I want to turn a mixture into a pure substance, sorry, I need to separate them. And therefore I need separation methods. I'm going to explain three of them now, and there are more, but you don't have to know them for now. There is filtration, which is based on size. It goes a bit like this. I have a funnel, then I have a filter paper, and obviously I have something to fetch the water. There's some stuff left here, which is what we call residue. This is what we call filtrate. And this is basically what you do when you make coffee. There's the coffee beans here, the coffee is here, and the coffee goes through the filter and the beans don't. So that is filtration. Then there is evaporation. And it's based on volatility. How easy does it evaporate? So basically I have just a cup with, for example, salt and water. And I'm going to evaporate the water, and the salt is left. So when I heat it, the water will evaporate, the salt won't. The water is more volatile. The volatility of water is higher than of salt. So that is why you can separate salt and water with evaporation. Then the last one is extraction. It's based on solubility. Oftewel oplosbaarheid. And what you basically do is you have a solid like this, and there are different molecules, so I'm just gonna make half of them black. I'm going to add water, and the black ones or the white ones dissolve, and the black ones don't. And then you get like this. The black ones are still there, and the white ones are in the water. So this is still solid, but the other ones, they are in the water, so they are dissolved. Then you can obviously filter again so that you actually get rid of this. This is what you do making coffee too, because when you have the beans, they are made of white and black ones. Half of it dissolves and goes with the coffee, and the rest of it will stay in the residue. On It's Learning, you will find some videos on those methods so that you can actually see it in real life.